My name's Colin Eberhardt. I'm the CTO of a software consultancy called Scott Logic. You probably haven't heard of us. We're relatively small, UK-based, and we build complicated things. And I'll leave it at that. I'm going to be talking to you today about AI. I'm sure you're all excited about it already. My hope is to make you even more excited. There's still a few chairs at the back if you'd like to grab those. So my talk is going to be a little bit of a roller coaster ride. My goal here is to get you all excited and then bring you crashing back down to earth. So hold on tight. We're going to start with a bit of a brief climb to the top. So I want to reflect on this question. What has made generative AI such a disruptive technology? And by this I mean, it doesn't matter whether you're looking in the technology press or BBC News, AI is everywhere. Everyone is talking about it. And I want to briefly have a look at why that is the case. So I'm going to keep it really, really simple. I think there are two qualities of this technology that are very notable that have contributed to it having such an elevated and sort of hyped perspective. The one is, for the first time, we're seeing general purpose AI models. So historically, if you've worked in AI, models were typically designed for a specific purpose. It could be for translation, for sentiment analysis. They were trained for a specific purpose, and they lacked that versatility. Whereas now, with large language models, they're able to adapt to a whole range of tasks without re-architecting, without retraining. That's a significant leap forward. The second point is they have human language APIs. Prior to that, if you wanted to use an AI model, you either had to be a Python developer or befriend a Python developer. And they're quite a friendly bunch. They're OK. I like them. I'm not a Python developer myself. Whereas now, if you want an AI model to perform a task, you just ask it in human language. You don't even have to host it yourself. You can just use the APIs on the internet. These two things alone, I think, have caused the current sort of AI models, the large language models, to be incredibly disruptive and very much hyped. However, it doesn't stop there. There are a couple of other points that I think have further built on this. The first is the emergent reasoning capabilities. And what I mean by emergent is this was somewhat unexpected to the people that put these models together in the first place. And by reasoning capabilities, what I mean is you can ask large language models a question, but if you ask them to reason about the question, it's been demonstrated that they perform better than if you just ask them the question directly. So this is a new emergent capability that people are getting very excited about. The other thing is use of tools. It's now quite straightforward to configure a large language model so that it can query the internet, so that it can use a calculator, so that it can actually write computer programs and execute them. These are two tremendous capabilities. And one thing that I think is quite interesting is reasoning and use of tools. If you take a step back, it's those two features which I think elevated the human species above all of the other species on Earth. So I think that bears some thinking about. Possibly a little scary. So I think the composite of these four things is why we're looking at what I believe to be the next technology epoch. And by technology epoch, I mean a big landmark improvement in our technology capability. Think the next iPhone, or possibly bigger than that. Think the internet or the printing press. And you might think, what do I mean by a technology epoch? My simple test for that is talk to a teenager. Ask a teenager, try to explain to a teenager what life was like before the internet. I've got teenage kids, and I tried to describe, they said, how did you meet up with people before mobile phones and the internet? We said, we agreed a time and a place. They said, but what if the person wasn't there? I said, you didn't meet them. And they cannot understand that. And I think in 10 years' time, AI will become so embedded in our lives that the next upcoming generation will find it really quite hard to understand what life was like before this technology. I think it's going to be really that significant. Like I said, this is a roller coaster, though. That's very much the sort of rose-tinted glasses, glass half full perspective. We're now going to start kind of tipping over the edge and start crashing back down to earth. What I want to do is tell you a few home truths about large language models. So you'll probably notice I'm using the terms interchangeably. Generative AI is a technology that generates large amounts of typically textual or image content. large language models are effectively, for the text generation, just another way of describing the same thing. So some home truths. Large language models are just statistical models. You might hear people talking about them having some form of intelligence. Some people go so far as to think of them as having some level of sentience. They're not. You have to remind yourself it's just a bunch of numbers. All they're designed to do is create the most probable output. What I find so astonishing is the reasoning capability that we see in them is nothing more than just statistics and maths at the end of the day. And if you've not come across these sorts of models before, I think it's quite useful to have a brief kind of interlude into a very early text generation model called a Markov chain. Hands up if you've heard of a Markov chain before. Oh, a few people have. Oh, that's fantastic. One of the things that I find is really good is you can demonstrate a Markov chain quite easily. I'm going to play a bit of a game with you, actually. If I say artificial, what do you say? Intelligence. Yeah, this is effectively what a Markov chain does. If I say the word artificial, from a probabilistic sense, the most likely word I'm going to say next is intelligence. However, if I say, oh, I'm sick of mowing the lawn, I'm going to replace it with artificial grass. Exactly. Now, what this is demonstrating that there's a probabilistic relationship between one word and the next, and in a simple model, you might just look at the preceding word and try to guess the next one. However, a more complex model would look at a number of preceding words to predict the next model, and you've effectively become human Markov chains. Now, in reality, with Markov chains, you train this probabilistic model on a body of text, and then once you give it a word, it will try to predict the next one. So this is a very simplistic example trained on A Song of Fire and Ice, basically the text behind Game of Thrones. And a Markov chain that looks at just the preceding word, once trained on that corpus, you give it the word the, and it comes up with 7, then in front of white fish in a huge blazes burning flesh. It's somewhat nonsensical, but you can see that it's got a sense of human language. A Markov chain trained on the 3 preceding words starts to sound a little bit more reasonable. He thought that would be good or bad for their escape if they can truly give... And this is how Markov chains work. They are a very, very simple probabilistic model for generating text. What you see with OpenAI's large language models is effectively this. The only difference is, well, the 2 differences, it's a more complicated architecture. They use the transformer architecture with attention and so on, all these things that, to be honest, I don't quite understand the architecture. And the training data set is huge, but fundamentally, it is just statistics. So if someone says to you, these things are intelligent, they can exhibit something which looks like intelligence, but they are not intelligent. They are statistical models. And this helps you understand some of the challenges with large language models. You've probably heard of the term hallucinations. This is where large language models imagine facts that are not real. However, once you understand that they're just statistical models, they don't understand facts. They are a predictor of the next word, or actually in reality the next token, but it's effectively the same thing. So hallucinations are entirely by design. We have designed them to be creative text generators. We haven't designed them for factual recall. And this is a fantastic quote from Sam Altman, who's the founder of OpenAI. Sorry, can someone just close that door? Thank you very much. I probably trust the answers that come out of ChatGPT the least of anybody on Earth. Isn't it lovely to own a company that has such a high value that you can be so dismissive of your own technology? But regardless, hallucinations are by design, and they are effectively an unsolved problem. Another thing, large language models are not databases. They can exhibit a level of information retrieval which is quite surprising. It's quite impressive. However, they are not designed to perform factual recall, again, because they're statistical models. It doesn't matter how much you train them. They will always exercise creativity. They will always, at points, create factual inaccuracies. So large language models, they're not databases. And this is where you may have heard of retrieval-augmented generation. This is starting to become a relatively sort of conventional large language model architecture, where the user request is sent to a model which predominantly performs reasoning and is a summarization engine. It's a chat engine, but when it comes to using facts, it uses another large language model which uses embeddings, we'll get onto that in a little bit, and then retrieves facts from a vector database. You don't have to understand the details too much here, but what's happening with retrieval augmented generation is facts are being fed back to the model as part of the input. So if you're asking it about, I don't know, the Breaking Bad TV series, rather than relying on the model knowing everything about Breaking Bad, it will probably know some facts from Breaking Bad. You're feeding facts into the model, and the model's primary purpose is semantic understanding of language and performing semantic, linguistic tasks rather than factual retrieval. Another thing that I think is really important to understand is its prompts all the way down. So what I mean by this is the text that you feed into the model is called the prompt. Your prompt is you ask it to perform a task, and it will then emit a response as a number of tokens. And almost all of the functionality that you hear about that's being layered on top of these models is effectively just more prompting. So you might have heard of concepts such as system prompts, where you tell a model to take on a certain persona. All that is a prompt. All that is a little bit more text being added to the top to say, you know, you are a system admin within a large organization. Even things like reasoning, as I've mentioned, these models are exhibiting reasoning capability. This isn't a new inherent capability of the model itself. It's all prompting. Actually, hang on. Did a text message arrive on that screen? Good. I didn't have it on Do Not Disturb, and one of my kids has just gone off on holiday. So I'm expecting a flurry of text messages. Right, okay, that's good to know. Okay, so this is actually, this is actually how you can teach a large language model to think. So this is all of the text that you supply to a large language model, and then it emits a response. And what we're doing here is we're asking it to answer a question, but we're telling it that it has access to these capabilities. It has access to a search engine. It has access to a calculator. And this is, again, taking a step back, this is pretty incredible stuff. In software engineering, normally when you connect systems together, you have precise API contracts between the various different components. Here, you effectively just write it out in text. This is crazy stuff already. But then we're asking it to use the following format. When tackling a question, we're asking it to go through again, I'm going to air quote it, a thought process of, given a question, have a thought about how I might tackle it, perform an action. The action will then result in another input, which is chained into your thought process, and you iterate until you feel that you have collected enough information to provide the answer. And again, to reiterate, all this is just a bunch of text which is being fed to the large language model, a statistical model that is spitting out the most likely next token. Yet, we're able to construct something that allows it to perform a certain amount of reasoning capability. And I had a go at putting one of these together. Within just a few hundred lines of code, you can create a large language model that is connected to various other components and perform problem solving. So I asked it, I'm from Newcastle in England, what was the temperature in Newcastle yesterday? And you're probably aware that these large language models, they have a training cutoff date. So if you ask it the weather yesterday, it will tell you the weather yesterday because it wants to answer your question. It will hallucinate and it will tell you, it will give you a number more often than not. Whereas here, now because of the prompt above, we've taught it how to reason. It understands to answer this question. What it should do is look for current information about the weather. It understands that the most logical next step is to search for the information it needs. You then perform the search on behalf of the large language model. You then feed that input back into the prompt once again, and here it determines that it has all the factual information it requires to answer my query. As I said, it's prompting all the way down. Almost all of the new capabilities and features you see from large language models are clever prompting. They're clever ways of instructing this large language model to perform a task. Another thing, prompt injection isn't a solved problem. Hands up if you've heard of prompt injection. Okay, quite a few of you. Prompt injection is quite simply where you're trying to subvert the behavior of a system that uses a large language model. And the fascinating thing is, the way that you subvert the behavior is effectively by talking to it, by persuading it to do something that it has been told that it shouldn't do. And unfortunately, the only defense, realistically, for this is to try to engineer your prompt in such a way that it cannot be attacked. It genuinely isn't a solved problem. There isn't a pattern that we can use that will prevent prompt injection. And you can see this playing out on the internet time and time again. Almost every time you see a release of a new and innovative generative AI technology, the first thing you'll find is within half an hour, someone's prompt injected it to find the system prompts, to subvert the behavior, to remove some of the protective controls. Everything falls apart, typically within about half an hour. Another problem, contrary to Gab's keynote, open source AI isn't actually winning at the moment. A number of you are aware of the Google's sort of leaked memo that we have no moat. And this is where what happened was Meta's Llama model was leaked, and a number of people in open source then capitalized on this by performing a whole load of fantastic innovations on top of this leaked code. They were able to make some fantastic strides in the capabilities of this model. They were able to run this model on much less resource-intensive hardware, for example. They did some fantastic things to a certain extent within isolation. However, what we're seeing is this is the share of licenses for models on Hugging Face. And what you can see from early 2023 onwards, there's been a significant increase in models that have restrictive licenses. More often than not, these are licenses that are non-commercial use only. And if you're familiar with OSI's definition of open source licenses, they technically shouldn't be calling these open source. That form of restriction is counter to what open source is. One thing I do need to point out, that scale goes down to 50% on the bottom. That really bugs me, charts that do that. So yeah, so what we're seeing here is a significant number have these restrictive licenses. It's not quite the 50-odd% that chart looks like. Another thing, LangChain. You may have come across LangChain. It's an amazing open source project that a lot of people are using to implement that kind of model architecture that I mentioned. LangChain is effectively a thin veneer. Again, to reiterate, almost all of the innovation here is around how you actually prompt a model. And LangChain has created a relatively thin veneer on top of that in Python, JavaScript, and a few other languages. It's not actually solving some of the inherent problems. What I find really interesting is LangChain now has a $200 million valuation. The value per line of code in LangChain is quite mind-boggling. Another thing, are you getting really quite depressed now? I'm going to stop soon. But one other challenge. AI is actually replacing humans right now. This is a chart from a website called Stock Performer. So this is a website and a service where they provide advice to people whose livelihood is stock photography. They provide advice about what sort of imagery is selling, what the margins they get on the various platforms. And what they discovered is over the past few sort of months, a significant number of the people in the stock photography market are now using AI-generated images. There's a kind of a divide happening in the community there. AI-generated images are actually selling really quite well. They can track the performance. They're selling well with a lower overhead in production. So AI is already starting to replace photographers, specifically within the stock photography industry, which is scary stuff. I know that there are some exaggerated news headlines about AI is going to replace all of our jobs. That's certainly not true. But there are markets where it is already making a significant impact. So yeah, here's some home truths. They're just statistical models, hallucinations by design. They're not databases. Open source isn't winning. It's prompts all the way down. LangChain is a thin veneer. Prompt injection isn't solved. AI is replacing human. That's pretty depressing stuff. And I haven't mentioned copyright or bias or ethics, or there's actually quite a long list. I must admit, I feel that some of the social challenges tend to get a little bit more of the airtime. Things like alignment challenges, copyright bias, that gets a little bit more airtime than I've pretty much stuck to the more technical challenges, just to really bring home the message that there's a lot of work still to be done here to make this into a technology that's general purpose and easy to use. So yeah, that's it. Is our dream over? Is the next epoch out of reach? I don't think it's all doom and gloom. What I think is we're going to be in for a bumpy ride. And if you look at previous technology epochs, the internet, for example, the dot-com boom and bust cycle, I think we're going to see exactly the same thing here. I think we're going to see a lot of people investing heavily, LangChain being an example, in generative AI without fully understanding some of the technical limitations, and I think they're going to lose, a lot of money and a lot of effort in doing so. So I think we're going to see a similar kind of boom and bust cycle. But I do firmly believe that there is genuine value sitting behind this. And the final part of my presentation, I want to talk a little bit about how we at Scott Logic have been approaching finding the value, finding the right path forwards. And I think it requires a slightly different approach to most technologies. I think comparing it to some of the other transformative technologies, things like cloud, that's been transformational to the software industry. However, in simplistic sense, cloud is taking a thing that happened here in a data center and it's moving it somewhere else. There are lots of benefits to that, but fundamentally that's what it does. It's of interest to your IT team. It allows them to be, more efficient. However, with this technology, the breadth of application is huge. You can use it to increase your operational efficiency. Developers are already using it with ChatGPT and GitHub Copilot to become more productive. You can use it to add additional capabilities to your products that you offer out to clients. It's actually quite hard to find a part of your business that it doesn't impact, whether it's your marketing team, whether it's part of your interview process. You can use it all over the place. So I think we need to take a slightly different perspective to how we try to find value from this technology. And the way we've been doing it is a fairly simple kind of iterative process. The first thing is education. I think to capitalize on this technology, you do need genuine understanding. There's a lot of hype, a lot of misinformation. You need to be wary of an understanding of the limitations because it's very easy to employ it in completely the wrong way. Ideation, as I mentioned, the breadth of capability, the breadth of application, it's ripe for brainstorming and bringing in people from your organization that you wouldn't normally engage with around technology. Finally, exploration. I think it's really important to actually just give it a go. And this is, feeding back to the education, giving it a go, finding out how it works, experiencing it for yourself. And one of the things I found really interesting, there was a Gartner publication just a few months ago where they surveyed 2,500 executives. 45% said that they've increased their investment in AI. 70% are investigating generative AI, 15% are piloting it, but just 4% actually have it in production. So you've not been left behind just yet. There are very few that have taken it into production, but there's a lot of organizations investigating and piloting. And for me, that is exactly the right way to do it. So I want to just end with a few examples of some of the projects that we've been working on ourselves. And they vary from the practical to the somewhat whimsical. But I thought some of them are good at illustrating this cycle in practice. So the first one, embeddings. Hands up if you've heard of embeddings. Just a few of you. I think this is something that is often overlooked. Now, embeddings aren't new. Embeddings are a concept that were developed about 10 years ago. But GPT, when it was released, is a more powerful implementation. But importantly, getting back to my early point, it's available via an API rather than having to have a friendly Python developer. So embeddings, in a very simple sense, are an encoding of the meaning of some text, whether it's a single word, sentence, or a paragraph. It's an encoding of that meaning as a high-dimensional vector. So you give it a bunch of text. With GPT, you get a vector that's got about 3,000 dimensions, which encodes the meaning of it. And what that means is if you get another vector which is very close, what that tells you is, semantically, the meaning of these two passages of text are very similar. And when we saw this, we thought, that's a really useful tool, and where can we apply it? So what we did was actually, we started using this a couple of years ago on our blog. So this is a recent blog post of ours about, we've just become a B Corp. If you're not familiar with B Corp, it's a really cool accolade for organizations to achieve. We're super proud of it, not wishing to pat our own backs, but at the bottom of every article of our blog, this is a fairly conventional pattern. You want to encourage people to keep reading your blog, so we recommend other articles that they should read. Previously, we just gave them some other articles from the same category. And again, that's a fairly conventional thing to do. However, we thought, can we apply embeddings to this part of our website? So what we did was we took the 1,000 or so blog posts we've got, we used GPT-3 to perform the embedding, and what you see on your right-hand side there is a two-dimensional representation of these 3,000 dimension vectors. It uses a thing called tsne that allows you to retain the clustering, the locality of these embedding vectors. And the color here is the category that we manually assigned to the blog posts. So what that means is that two dots close together are blog posts that are semantically quite similar. And as we zoom in on some of it, we see that there are articles that we have classified as being in different categories that when you read the title, semantically there's a lot of similarity here. You see a number of blog posts about the UX of open banking, or demystifying open banking, or what is it? Open source in financial services. We've classified these into different categories, but the embeddings are telling us that the semantics of these articles are fairly similar. So what we did, and what we still do now, is our related articles, we use GPT to find the nearest neighbor article from the rest of the blog. And what we found through Google Analytics is we've created a threefold increase in the engagement on our blog. We were actually able to make a measurable impact. The number of people that click to read another article is increased threefold, which is amazing. And a very important point here is there's no problems with hallucinations, prompt injection, or any of the other problems that I've told you about. Embeddings are what I would call a safe tool to use. And thinking ahead, one of the things that I do as a consultant is quite often we'll get dropped into a client and we might be working on their cloud strategy, for example. And you'll end up trying to ingest manually a large amount of data, not data, textual data. They'll point you at their Confluence pages, a bunch of PDF documents, and more often than not, they're all saying the same thing in a slightly different way, and they're out of date. What we're looking at is using embeddings to allow us to highlight paragraphs of text which are, in this instance, unique with respect to the corpus of text that they live within. We're looking at ways of can this help us to home in on the important bits of information amongst a large body of text. I think embeddings are going to be fantastic. Everyone else is looking at chatbots. We think embeddings. But we also built a chatbot because, everyone builds chatbots. This is a chatbot that we built called ScottBot, and I was going to do a live demo, but I'm a coward. So this is actually, I've got it on my phone, and I'll give anyone a demo later on, and it might work. I did this in the hotel room last night. So one of the things I asked it is, what is Finos? And it says, Finos stands for the FinTech Open Source Foundation. So this is a chatbot that's that's able to call out to the internet, retrieval augmented generation, to be able to answer questions. And we're actually using this internally, and people are finding it tremendously useful. When I'm traveling, I more often than not talk to ScottBot now. But the thing that's important is it's ScottBot, it's Scott Logic's chatbot. So we want to ask it Scott Logic specific questions. So I asked, I've just been to one of their events. How do I claim travel expenses? And it comes back. It says, to claim travel expenses for an event you attend, it has the following process. And this is because, as well as accessing the internet, it can access our internal document stores, Confluence, Google Docs, that sort of thing. So it's a gateway into our own sort of knowledge base. And part of the interesting exercise here is the prompt engineering required to get it to understand that there are certain types of question that it should go to the internet, certain types of question it should go to Confluence. That's too many words. Yawn. Explain it to me in 20 words or fewer. To claim travel expenses for a conference, raise an expense claim in the portal with supporting documentation. You can ask it to perform summarization. And one more time in rhyming slang. To claim travel dough for a conference show, hit the Scott Logic portal, let your expenses flow. It's a lot of fun, actually. When we first released this internally, we ended up spending quite a lot of money. And we looked at the logs, and most people were trying to get it to tell jokes, and we're asking it, which is the best Scott Logic office? And it always said Newcastle, because I'd engineered it that way. But we learned some really important things along the way here. And I think one of the most fundamental is you still need labeled test data. Test data is still one of the biggest challenges in AI, and generative AI. Large language models haven't solved that, and I'll explain what I mean. Before you put something like this into production, you have to find a way to describe the behavior that you want. You have to find a way to encode that in such a way that you can test. Because if I go back and I change the prompt, if I change the way that I address this model to change the behavior, I need to have a test suite that enables me to make sure that I haven't made any regressions. I could tune it so that certain words indicate that it should use Scott Logic Confluence rather than Wikipedia. But a knock-on impact is it might perform worse in another area. Now, and this is effectively labeled test data. So what we have for ScottBot is we have a test suite of a few hundred tests where we have, for a given question, this is the answer that we would like you to give. However, there's another challenge there. Because it's AI, there are shades of grey. Typically, when you're doing software testing, there's quite a binary response. It must do this, it should do that. With AI, there tends to be well, that's slightly better, or that's slightly worse. And being able to evaluate as well whether a response is roughly equivalent to the response in the test data set, that's not easy either. There are many acceptable ways of answering the same question. So anyone like to guess what the standard way to evaluate whether a response roughly meets the requirement is? Want to guess what that is? You use a large language model. You use a large language model, you prompt it, and you say, given these two responses, are they equivalent? And again, you use large language models to test large language models, which is a little bit baffling. But also, this is on Azure, our test failure report. And again, this really threw the testers. They're used to having a test failure report which sits at, a test success report which sits at 100%. If it drops below 100%, everyone rallies around, we fix the bugs, it goes back up to 100%. Whereas here, it starts off at around about 50%, and we're now at about 75%. It's also non-deterministic. You can run the tests again, and you'll get a slightly different response. It's a game of statistics. So this is why I think exploration is important. The engineering approach here is slightly different. It's slightly alien. It may not be the engineering approach that your team is used to. And finally, I guess, taking a step back, from our experience, these are fantastic tools for rapid prototyping. You can just ask it to do something, and more often than not, by asking it the right way. If you've used ChatGPT yourself, you'll find that you have a few iterations, and then after a few goes, it does something truly amazing. But that's a very rapid gratification. It solves your problem. But the path to production is still quite a long journey. It's great at the very early stages. It's hard work to get that into production. And also one other thing, be very wary of selection bias. People might try to get it to do something 10 times in a row. It doesn't work. They find exactly the right wording. It does something amazing, and that's what they put on Twitter or LinkedIn. Selection bias is rife. The final one I want to quickly talk about, another cycle we're going through, is prompt injection. I think that's a fascinating topic. Funnily enough, when we released our chatbot to the 450 developers in Scott Logic, almost the first thing they did is they all attacked it. They all tried to subvert the behavior. They all tried to do prompt injection. A number of them succeeded. It wasn't perfect. And we decided we needed to educate ourselves about prompt injection. And the team behind this, what they decided was, rather than doing a kind of a textbook approach, they decided to create a game. So we've created a game which is a sandbox for experimenting with prompt injection. And you can go through various different levels. And what you can see here is you can employ various different conventional defenses. It's got documentation about all kinds of attacks: payload splitting, jailbreaking, partial reveal, prompt leaking, token smuggling. There are all kinds of fascinating and exciting types of attack. Anyone want to guess what the most typical defense people use against prompt injection is? It's a large language model. More often than not, what you'll do is you'll have a large language model which is effectively trained to look at the input from a user and determine whether it is trying to attempt a prompt injection attack. It's kind of, yeah, it's shaky layers on top of shaky layers. So at the moment, we're in the process of open sourcing this. We're hoping to make it a game that anyone can play once we've got on top of some of the cost management problems, because it can be relatively expensive to run. So we're trying to work out a way of doing some cost limitation and make sure we don't run up a horrific bill. But we've learned a lot about prompt injection through developing this game, and I think that it's a fantastic tool that I hope others will use. So yeah, that brings me to the end of my talk. And as I said, I really would recommend that definitely educate yourselves. Find out, as well as getting excited about the strengths, learn about some of the weaknesses. Don't fear them, but learn how to use your knowledge of the weaknesses to be more selective about where you might use this technology. Ideation, as I said, brainstorm, bring in the kind of people that you wouldn't normally bring into the conversation. And then finally, exploration. Actually, just give it a go, play with it, build things for your own organizations. These steps have really helped us. We've learned a lot, and we're doing a few projects with clients that I'm afraid I can't tell you about. They're super exciting. I might tell you about them off stage if you like. But we've learned a lot through going through this process. Finally, my final point is I do think this is the most exciting technology I've seen in about the past 20 years. You know, more exciting than blockchain. It's more exciting. I knew that would get a laugh. It's more exciting than cloud. I think because of the breadth of potential applications here, I really think it is a technology that's worth getting excited about. So thank you very much. I hope you enjoyed that. And cheers.